Hello, fellow mathematicians. You are back with Miss Ledbetter, and it is time once more to do some more math. Today, we're going to be looking at our rational functions, taking the inverse of each of these rational functions. We've done inverses before, so it's not anything new. Should go pretty simply, pretty easily. It's everything that you already know how to do. So we're just going to do a real quick short video. But as we go through the video, make sure that you are keeping track with your notes. On page 43 in your interactive notebook with our rational functions unit, make sure you're keeping up with that. That is part of your 9 weeks test grade, so make sure you're keeping up with that notebook. Before we get started, we're going to remind ourselves, how do you find inverses? What are inverses for each function? So remember that every f of x just means y, so f of x, we replace that with the y. And then to find the inverse, that means we are switching the x and the y. Switch their places, and then once again, just solve for y. So we can put it back into our y equals form, and then replace our new y with the inverse function of x. So let's look at this first example. We have a function of x such that 3 is being divided by x plus 1. Notice in this original function that we are limiting the domain for the value of x because the denominator cannot ever equal 0. Since x is the only thing in the denominator, x itself cannot be equal to 0. So there's a limitation on the domain even before we begin. Whoops. All right, so then let's actually look at how do you find the inverse for this function. So first thing, just remember that f of x just means y. So we're going to replace the f of x with a y. And then now we are going to switch the x and the y. So rather than y equals 3 over x, now it becomes x equals 3 over y plus 1. So then now we need to solve for y. So to get the y by itself, first thing I'm going to do is subtract the 1 to the other side. And now I just have 3 over y remaining. And in order to get y by itself, I have to get it out of the denominator. And the denominator of a fraction just means that we are dividing. So the opposite of dividing means that I have to now multiply both sides of my equation by that denominator, which in this case is just y. So I'm going to multiply both sides by y. So then I have y times all of x minus 1 is now equal to, whenever I multiply by y with a denominator of y, those are going to cancel. Now it's just equal to 3. Now I don't want to do the distributive property because I'm trying to isolate the y. So in order to get y by itself, I have to get rid of this x minus 1. So I'm going to take all of x minus 1 and divide everything in this equation by that x minus 1. And then whenever I do that, if I have x minus 1 and divide by x minus 1, that's going to cancel out, leaving me with my y equals, now is 3 over x minus 1, and then replacing my y with back to the inverse function of x. So now my inverse of x is that 3 over x minus 1. So then in this domain, the x cannot ever be equal to a positive 1 because x cannot equal 0, or the denominator cannot ever equal 0. So then we moved from an original domain where x cannot equal 0. Now, with the inverse, x cannot equal 1. Something to consider when you are taking the inverses, especially for rational functions. When you're looking at these ratios with fractions, denominator cannot ever equal 0. So then let's look at maybe something that's a little bit more complicated. If we have a function of x such that 1 is being divided by all of x plus 9, and then we're subtracting the 7 from that. So again, looking at considering the domain, it has a limited domain because x cannot be equal to a negative 9. Denominator cannot ever equal 0. So to find the inverse, let me change colors. To find the inverse, remember that f of x just simply means y. So that just says y equals 1 over x plus 9 minus 7. So then I'm going to switch the y with now x is equal to 1 over y plus 9 minus 7. And then now I need to solve. So in order to get the fraction by itself, first thing I need to get rid of is move that 7 to the other side. So then it becomes x plus 7 is equal to 1 over y plus 9. Then I need to multiply by the denominator because y is in the denominator of the fraction. I need to get rid of that denominator. So I'm going to multiply everything by my denominator, that y plus 9. So I'm going to multiply everything times the y plus 9. And then, so now my equation just says y plus 9 times the quantity of x plus 7 is equal to, now, because I multiplied the denominator, that cancels out, is now just equal to my numerator, which is 1. But again, I wanted to get the y by itself. So now, similar to what I did before, I want to move the x plus 7 factor over to the other side, and I'm going to do that by dividing. So when I do that, I then get y plus 9 is equal to 1 over x plus 7. Then I still need y by itself, so I'm going to move the 9 over to the other side. So now my final answer, y equals 1 over x plus 7 minus 9 as my final answer, and then replacing that with the inverse notation for the inverse function of x. So then now I am limiting the domain. My denominator now becomes x plus 7. So now my domain has been limited because x cannot ever be equal to a negative 7 on this particular function for the inverse of that function. So a couple of tips whenever you are trying to find the inverse. First thing that you need to consider is that you always work from the outside in whenever you are finding inverses. Always work from the outside in. So whatever was being added or subtracted, that's what you're going to do first. Cancel that out, move it to the other side. Whatever you have in the denominator, you're going to multiply. Everything gets multiplied by that denominator, and if you multiply the fraction by its own denominator, then that's going to cancel out, leaving you with just the numerator of that fraction. And then you always want to, the numerator is always going to be your last thing, the last whatever that needs to be, the last value that needs to be eliminated. So the numerator is always the last thing. So don't worry about the numerator. First, you're going to get rid of the add or subtract. Then you're going to multiply everything by the denominator, move that to the other side. Whatever you had over here on the other side, if there was something with the x in the denominator, then you are going to have to subtract or add that back to the other side so that you can get your y by itself. But the numerator is going to be the last thing that you would ever have to worry about. So you're not actually really going to do anything with the numerator on that. So those are just a couple of examples really quick. We'll do some more work in class, but you have a general idea of what inverses are. So you just follow the exact same procedures that we've done before. And like I said, as always, if you have any questions, need help, concerns, issues, whatever, feel free to stop by and see me. I am available every day before or after school. So check it out. Have a good day.